have understood how the electrons move inside the material, that is how the electrons move inside the conductor, then from that particular concept I have started to define you the particular average velocity when electric field is applied, and that particular term is known as drift velocity. So the today's class is all about drift velocity. So as I have told you in the previous class, when electrons are moving inside the conductor, when electric field is applied, the electrons will be moving in a fixed direction from negative terminal to positive terminal. Suppose there are n number of electrons present inside the conductor, then velocity of the first electron may be say v1, velocity of the second electron say maybe v2, velocity of the third electron may be v3, velocity of the nth electron may be vn. So these are the velocities of n number of electrons which are contained inside the conductor. Then when you take the average lotokpa taragadi kai taurani loinamak tinsinaraga karina divide taurani the number of electrons divide taurani. And this particular average velocity of the electrons, when you apply electric field inside the conductor, this is known as drift velocity Vd. And this drift velocity will not be zero, because these values are all positive values, and this positive values, when you add it and divide it by the number of electrons, it will be always positive. So there is no way the velocity can be zero. Right? So drift velocity is defined our drift velocity is the average velocity of the free electrons inside the conductor when electric field is applied. Electric field applied to so electric field applied to electrons into the velocity to the average velocity to drift velocity. So this is the very definition of drift velocity. Then let us try to derive the expression for drift velocity. Drift velocity my expression is derived from suppose you have a cylindrical conductor like this, like what we have done in the previous one. Then when you consider only movement of only one electron, and altogether see a number of electrons might be present inside the conductor, then Nasai can say when the electron is applied an electric field E, it will be moving from the positive terminal to negative terminal to positive terminal. Let us represent the velocity by Vd, drift velocity, and this Vd is the drift velocity, and the electrons might be accelerated. See, electric field applied to E vector say applied to this electron might be accelerated. Let A be the acceleration. Okay, let A be the acceleration of the electron, one particular electron. When electric field is applied across the conductor, let us take only one electron for the time being, and this electron will have a mass m. Then, as you know, from Newton's second law, force is equal to mass times acceleration. So this is the force which is to be experienced by the electron. Electron, as you know, electron has a mass, and the amount of force to be experienced by this electron by applying Newton's second law is F equal to ma. Then from electrostatics in unit number 1 also you have learned this for electrostatic force is equal to charge times the electric field E. Charge the electric field applied to electrostatic force money. Then this instead of E, this should be replaced by E. And this electrostatic force will be provided by this Newton's law, Newton's force. Force exerted on a mass when you apply force, when acceleration is being acted upon, F equal to ma sina kari provide tawne sigi electrostatic field se apply electrostatic force supply tawne. That means kari high no in high se this Newton's C force ani se managa da uni hai ko ma se kari ga manarani e se ga manarani. I believe the electrostatic force will be provided by this mass times acceleration. Newton's second law of electrostatic force ka mo yan gi kan ni apun bu ni. Asidai nang na acceleration e putok tar ga di kai tar ni e by m tar ni ko adui tar ga di. Let us think about the n number of electrons now. Suppose n number of electrons are present. N number of electrons are present. Right. Adu abi tar ga di. For the time being, let us name this particular equation as 1. For the first electron, when you apply the electric field, equation of motion dagi v1 velocity of the electron when electric field is applied should be equal to u1 plus a into t1. T1 sina first electron duna chakpa matam da changba time ni. Second electron gi v2 du di kya ta ni u2 plus a t2 ta ni ko. Third electron gidi kya tane minus matang lag pasina Vn nth number nth electron ni my velocity do kya tare ni have matanda un plus a tn tare ni. These are the velocities of the electrons. Velocities of the electrons v1, v2, v3 up to vn. And these are the velocities of the electrons when electric field is applied. Then let us take the average of all these velocities. The equation is lối tiền chân se left side cái ta v1 plus v2 plus v3 v3 to lối này nhau rồi nè to hai something là gì vn một tiền chân đấy rồi divided by n rồi gì left side cái ta nè right side cái ta nè lối tiền chân này n là divide theo sẽ hay có u1 plus u2 plus hay là cái áp tiền chân này nè un divided by n si lấy đấy. Aduga kari wali e se common lo ya đấy plus e lấy đấy ni time t1 plus t2 plus t3 up to kya putin sin đấy ni tn divided by n dollars. Adding all the equations and dividing by number of electrons n rồi din. Then adu the left side ki se kari ta hai. Left side ki se dip velocity ki definition to taram. Average velocity of the electrons when electric field is applied. The left side is going to get sin the velocity v d sin and then average velocity of the electrons before electric field applied to which in the mamang class diagram this should be always equal to 0. So this can be substituted by 0. Then e thamasi and this time taken mayam to be average to average relaxation time going. So this tau is known as average relaxation time. The average relaxation time is at the end of the when electrons are moving inside the material, they may happen to collide. So the average time taken between any two successive collisions, that is known as average relaxation time, and it will be given by the sum of the time taken divided by the number of collisions. Okay. Adoi ta ga di ke dore b d se ke dore ni kai ga mana ni a to di ga sai kai ga mana kre e by m ga mana re divide into tau. So this gives you the expression for the drift velocity when you apply electric field. So what is E, small e? Electric field, small e is the star scattered by an electron. E is the electric field applied. Mass is the m is the mass of the electron. M is the mass of the electron, and tau is the average relaxation time. Average relaxation time have to electron singula. Conductor to remove the book and the thing in the sun time I am doing average, so that is known as average relaxation time. So this gives you the expression of drift velocity. Now when a unit electric field is applied, say unit electric field am apply to masai conductor sida I can apply to electric field or unity on a lower one on a lower, then that drift velocity applied per unit electric field set masi ko na kay ko ni ham mobility ko So your mobility will be defined as mobility will be defined as the drip velocity applied per unit electric field applied. Adu taragadi nang nasida drip velocity nang sida hapsing gi taragadi kai tarani se kita e tau by m lere imaka ida e sima katanaraga adu mobility mu se kai tarani e tau divided by m gamana. So this gives you the expression of mobility, and mobility is nothing but drip velocity per unit electric field applied, and its expression is given by e tau by m, and that of drip velocity is equal to e tau divided by m. Right?